Ladies and gentlemen, welcome back. My name is Jeremy Champa. Today we're going to be talking about the October 2020 SAT. Let's jump right in. So the first thing to know, we're going to start with number 15. Numbers 1 through 14 may come in another video. If you don't see those videos, feel free to ask me to make videos for those questions. I'll be happy to answer any individual questions you have or all of them. But we're going to start with number 15 today. So number 15 is about these box plots. Here's what you got to know about box plots. The outside edges are the max and min. Min, I should say first, and then max. And then you have these sort of boxes in the middle. And sorry, my line's going through the boxes, but like this line is the median. And then this is the 25th percentile and the 75th percentile. So all they want to know in this question is what is the range if you combine all the data? Well, you take the lowest minimum, which is 10, and the highest maximum, which is 160, and you subtract those. 160 minus 10, answer would be 150. Cool. So there's more stuff to know about box plots for other questions, but here you just needed to know max and min. Okay, 16. 16 is a question about exponential graphs versus quadratic equations. Remember quadratic equations, you've probably seen them before. They look like, something like this. And then we have exponential equations. Exponential equations kind of look like they have some sort of a starting point, and a lot of times they just grow in a lot of cases as x grows. So the first two are exponential. The second two are quadratics. And quadratics don't really make sense for bacteria doubling because we have no negative values where they're going to grow. It doesn't really make a lot of sense. But even if you didn't notice that, what you could do is you could try out some values. If you try x is 0, you need to get y equals 150,000. And what you'll find is all of them give you that. If x is 0, the big thing to think about for A and B is that anything to the 0 power, so 150,000 to the 0 power, is 1. So actually that one's out. You can cross off A right away. I hadn't seen that. But B, however, you can't cross off right away because 150,000 is not raised to the 0, it's times 2 raised to the 0. And that's the same thing as 150,000 times 1, which is 150,000. So to be clear, 2 to the 0 or anything to the 0 power is a 1. So that's cool so far. And it's going to end up being the right answer. I'll prove to you why C and D are wrong, though. Look, first, when x is 0, you're going to get C and D are going to work because you're going to get 0 squared, which is just 0 plus 150,000, or 2 times 0 squared plus 150,000. It's going to work no matter what because the zeros make it such that you're just going to get the 150,000. That's what this question says is you start at 150,000, you double every hour. So then what you might do is just try out like x is 1. In 1 hour, you should double the y value and get to 300,000. And that's how you get rid of C and D. Because if you have an x value of 1, C is just going to be 1 plus 150,000. And that's not 300,000. D is just going to be 2 times 1 squared, which is just 2, plus 150,000. That will not get you where you're trying to go. However, A is already out, and that's wrong again, even if you weren't sure on this one, because 150,000 raised to the power of 2 times 1, or just squared, is a huge number. I don't know what it is, but it's huge. It's 150,000 times itself. We want to multiply it by 2. That's why answer choice B is going to work, because it would be 150,000 times 2 to the first power, which would then give us 300,000. So instead of rewriting that, I just kind of wrote over this. 150,000 times 2 to the 1 is 300,000. And then what this means, just so you understand this type of equation, is just how many times you want to multiply by 2. 0 times would give you 150,000. Do you want to multiply by 2 once? That would give you 300,000. Do you want to multiply by 2 again? Then you would have 300,000 times 2, or 150,000 times 2 times 2. You would be doubling every time you multiply by 2 again. That's why B is the correct answer. But even if you didn't know that, you could use real numbers to prove it. Right? Easy real numbers. X is 1, X is 0. All right, number 17. Look, at this point of the test, when you see systems of equations, it's about noticing something, right? It actually doesn't matter what happens to this piece if you get the other piece to be 0. That is, if y equals x plus 3 times x minus 7, and y also just equals x minus 7, I added the parentheses, but just so you can see the similarity. Look, if this number is a 7, I'll put this. If you put a 7 in here, here, and here, what you're going to get is you're going to get y equals 7 plus 3, which actually doesn't matter because that's getting multiplied by 7 minus 7, which is 0. So it'd be 10 times 0 or just 0. Down here, you would get 7 minus 7, which is just 0. They want you to notice that pattern. You know, the other thing you could do is literally just try out these numbers, and that would be a very useful way of thinking about the question. You know, try out the 3, see what you get. Try out the negative 3 if you need to. But noticing that pattern, noticing that it will be 0 here and 0 here, which makes the whole thing, this entire equation 0, if x is a 7. Cool. So hopefully that's helpful. You know, the other way you could do this question if you weren't sure is you could FOIL out this first part. You get x squared, you get negative 7x, you get positive 3x, and you get negative 21. That's just foiling out this top. Outside negative 7x, inside 3x, last negative 21. Now you still have y equals x minus 7. You could now just set these equal to each other and do a bunch of algebra. So this would be negative 7x plus 3x is negative 4x. You could bring these pieces over, so you're now subtracting x to get negative 5x, and you're adding 7 to get negative 14, and then you'd factor. And if you weren't sure how to factor it, what you would do is you'd put an x and an x. You'd say this sign tells you, if this was positive, you would have two of the same signs, right? Either two negatives multiplied to be a positive or two positives multiplied to be a positive. In this case, it's a negative, which means I need one of each, because only a positive times a negative will give you a negative. And then what you need is two numbers that multiply to be negative 14, add to be negative 5. That means the bigger number should be the negative number. And the only things that multiply to be 14 are 2 and 7 or 1 and 14. 2 and 7 seem like you get a 5. And you would if you had a negative 7 and a positive 2, which means the x values of x equals negative 2 or x equals positive 7. Here's the only one that's present in the answer choices. Though negative 2 would be an answer to this question, it's just not present there. The fact that they're dealing with a positive 7 is testament to the fact that they're looking for you to notice this pattern, x minus 7, x minus 7. Okay, let's keep going. All right, 18. Instantly, I'm thinking about it's a translation question. And one thing to be on guard for, it doesn't happen here, but I just want to show you something. Look, if you have let's say you have a box that's 3 yards by 3 yards. You say that's 9 yards, the area. If you get asked about area or volume with these units, change the units on the individual sides. Because if you were to be asked, like, what size is this? I know it doesn't look exactly the same. I'm just kind of drawing stuff. Same size in yards, if you were to put it in feet, would be 9 feet by 9 feet, which is 81 square feet. I should say 81 feet squared is usually the way you write that. Yards squared here. Look, that's counterintuitive. If you ask people how many feet would be an area of 9 square yards, people usually just multiply by 3 and they get 27. But you have to actually multiply both of these, as you can see, by 3. 9 feet, 81 square feet. Just something to consider, not really relevant to this question, but something that comes up on translation questions. You want to know what the possibilities are on each question. There's a wide range of numbers here. Let's see if we can kind of maybe get to a place where we can understand how big this number should get. 320 million, I don't care about the millions. We're all in millions. 320 feet per second. Okay, in yards per minute? Well, this would be 100 and... I don't know exactly what... I guess it would be 120 20 over 3, which is roughly, a little bit less than 7. 106 or 107. It's really close to 107. So I'm going to say 107-ish yards per second. And then in a minute, feet per second, 107-ish yards per second. Oh, and then multiply that by 60 to get in a minute. Right? If this is in 1 second, then you figure out what's in 1 minute. Multiply that by 60. So just think like 100 times 60. What is that? That's 6,000. So the only number that's close to that is C, and it makes sense. A little bit more, 107 instead of 100 times 60. So 6,400. 6,400 million yards per minute. Look, that's intentionally confusing, all those like translation pieces. Notice that I just sort of estimated 320. I said 107-ish. I know you could use your calculator. Feel free to use your calculator. Just don't get lost in your calculator. That's what happens to a lot of people. I have a calculator. I could go grab it and use it on this question, but I don't think it's the best way for me to ensure that I get this question right. Keep your logic at the front of every question you do. The front of your mind is the logical part of your mind, not the calculative side of your mind. Okay. Number 19. This question is an interpreting equations question. They say, what is this term 10268 is what? I mean, start with, this is the wise ass answer question. This is on every single test. Sorry if that's too much of a cuss word for you, but the wise ass answer. By that I mean to say, start by being like, look, it's the y-intercept, right? It's like, that's the y-intercept. It's always in that place, right? When t equals 0, we get s equals 10,268. So I start by telling myself that's the y-intercept. What's the y-intercept? It's when x equals 0. What's x? T. Okay, what is t? T is years. So at 0 years after 1969, the number of students. That's answer choice A. Cool. I hope that helps. They always ask you about either slope or intercept every time. And all you got to do is, when I say wise ass answer, that's me breaking it down into pieces so I don't get confused. I know I can get this one right if I go in small pieces. My wise ass answer idea, if you haven't heard me talk about it before, comes from the idea of like being a kid in a class and like the teacher calls on you and you just don't care and you just are like, what'd you think of the book last night? It was good. Tell me more. I don't know. I liked it. Why did you like it? Because of the characters. What did you like about the characters? I thought they were cool. Like, I'm taking small, nondescript steps. I'm saying, okay, it's the y-intercept. Okay, what's the y-intercept? It's where x equals 0. Okay, what's x? It's t. Okay, what is t? Years. Okay, so it's the value of s when t is 0. Years is 0. What is s? Number of students. That's the way I do it. Like, it's like pulling out tiny little pieces of the answer, little bit at a time. That's how you make sure you don't get lost. Usually when people get those questions wrong, they think they got them right. It's not that they think it's hard. It's that they just kind of missed a step. So number 20. Anytime I have a paragraph like this, I just jump to the end. It says, which of the following best describes the slope of the graph in the equation in the xy plane? I mean, look, I know that the slope is 44. That's the slope. Starts at 500. Slope is 44. Let's just figure out what x and y are. A company found that the average customer rating of a certain product can be used to estimate the total income for that product according to the equation, where x is the customer rating. Every time customer rating goes up by 1, y or income goes up by 44. So income goes up 44 if customer rating goes up 1. That's answer choice D. Right? So x is, you could start by just writing down something like x is customer rating, y is money. And then you say when x goes up 1, y goes up 44. I know that's not very official, but that's the way I think on this test, and it's really helped me. So I'm thinking about these questions, like I said before, in a super logical way and not in a super mathematical way. It's really easy to look at that and be like, I don't know, something about the 44. And there's a lot of answers that have to do with that. But when x goes up 1, y goes up 44. That's the meaning of slope. Rise over run. Change in y, dollars, the amount that the dollars change every time the x goes up 1. Okay. Let's keep going here. So that was 20. Here's 21. How many solutions does the system of equations have? Okay, there's something I know right away. It's not exactly 2. Because these are both lines. How do I know they're lines? They just have an x and a y. They don't have any squareds. Anytime you just see x's and y's, that's just a line. Right? You could, and we'll find out what's up with this line here. What we'll do is I'll take the first equation, 2x minus y equals 3, and I'll move stuff around. Subtract the 2x, I'll get negative 2x plus 3. Divide by negative 1, multiply by negative 1, whatever you want to call it, 2x minus 3. Second equation is, I'll just circle this so I have it. Second equation, 4x minus y equals 3. I can actually already tell that this has exactly one solution. I'll tell you why in a second. Negative y equals negative 4x plus 3, multiply by negative 1, divide by negative 1, call it what you want. You're just getting rid of this sign. Positive 4x minus 3. Look, here's what I know now. They have different slopes. They intersect once then. Any lines that have different slopes, they're going to intersect once. I don't even care where, just exactly once. How would we have 0 solutions? Well, if we had exactly the same slope, we would have parallel lines, right? No matter what the y-intercept, well, I mean, not say that. If the y-intercepts are different and you have the same slopes, then you would have parallel lines. If you have the same y-intercept like this question has, and the same slopes, then you don't have two separate lines. You have the same line, which would have infinite solutions. It would just keep crossing itself everywhere. Right? So if this had the same slope, it already has the same y-intercept. So I know that it has that. In that case, it would have infinite solutions. Same slope, same intercept. So you could write down same slope, same intercept, infinite. If you have different slopes, then it doesn't matter what the intercepts are. Different slopes will mean only one intersection point. And then if you have the same slopes but different intercepts, same slopes, different intercepts, those are parallel lines. They have the same slope. They start in different places. Those have no solutions. They never cross each other. So just to be clear, solutions mean intersections. Right? That's what that means. Now, I told you I kind of knew right away. As soon as I started doing this question, I kind of realized I'm going to get different slopes. I'm just going to subtract these x's over. I don't have to divide by anything other than that negative sign. Those slopes, are going to be different, so I know I'm going to have just one solution. Okay, cool. You could take an algebraic approach. I guess I'll back up and just say this. Look, you could take an algebraic approach. I'll just take the equations, and what you might do is you say, if you needed to actually know what the solutions were, let's talk about that. If you needed to know what the solution or solutions in a different situation, if you needed to know what the solution to this linear system is, what you would do is you would multiply the first equation. I mean, you could do all sorts of things. I don't like to do substitution on this test. I've seen too many times that goes wrong. I'm going to multiply this situation. Well, let's just subtract the bottom from the top. 2x minus 4x, negative 2x. Negative y minus y, that's the same thing as negative y plus y, is 0. 3 minus 3 is 0. Negative 2x equals 0. X divided by negative 2 equals 0. When x equals 0, we have an intersection point. Of course that's the case. We knew this before. They have this same, I forget what the slopes were, negative, weren't they? No, they were positive. Positive 2 and then positive 4. So they would intersect at the y-intercept when x is 0. And you could go figure out what that is. In each case, you could figure out that x is, I guess it's -3, so I plotted these wrong. They should really be down here. Something like that and that. Lines that do that. Okay, so that's enough of that question. All sorts of things. If you're wondering why I don't do substitution, you'll see it on other system questions, and I'll talk to you about that at the time. Which of the following could define function r? Okay, so here's what I know about function r. They say a, b, and c are positive constants. In the normal equation, I'll show you the different forms. Ax squared plus bx plus c. That's standard form. The a's and b's and c's mean different things here, but they're just placeholders. If you have a x minus b, what you have here is this thing. These things actually tell you something very similar, which is the steepness and whether or not they're positive or negative. This thing tells you the y-intercept. This doesn't tell you that much, that obviously. I mean, there are things that you can learn about translations and stuff from this b. But these b's and c's are the center. Anything that happens in parentheses is weird. Parentheses are always a pain in the ass, kind of weird. So if you see x minus b, that means that the center is positive b, or the vertex is positive b. And outside of parentheses, it's not weird. So in this case, positive b, positive c. So if this is positive, this tells me opens up. Positive opens up. By that I mean something like this. In the case of our equation, it opens down. So that's negative and opens down. So what do we know? We know that A is negative. That means it's either answer choice A or B. C and D are out because they're positive. They say A, B, and C are positive constants. So negative A is a negative number if A is a positive number. I know that sounds confusing, but it's simple. If A is 2, negative A is -2. So this opens down, and it has a positive vertex, which means I need the weird parentheses negative sign and the positive C. Answer choice A. So that's about knowing those few things about styles of equation. This is called standard form. And then the one that we're asking about here is vertex form. And it's good to know that. But look, the standard form is way more important on this test. The vertex form doesn't come up that often. If you just remember that things in parentheses are weird and things outside of parentheses are not weird, that might be enough on a question like this. Okay. So, number 23, right? So, which of the following is equivalent for x is not equal to root radical 2? So just to be clear why they're even saying that. If you have a denominator of 0, undefined. Anything over 0 is undefined. So they don't want us to get a 0 in the denominator, and root 2 minus root 2 is 0. So that's why they're getting rid of that. Now, there's a trick that comes up a lot on the SAT. It's this idea of difference of squares. Look, and I'll back up just to explain it to you. Some people have this instinct, and I'll show you two versions of the same instinct. Some people have this instinct to say, look, I want to get rid of this root 2. Let's square it. And then they'll say, let's just square the top and the bottom. That's not the same thing. To be clear, this is not equal to the top squared over the bottom squared. And if you want proof of that, give yourself some numbers. Like if you said 2 over 4, or let's use numbers that wouldn't simplify that easy. 2 over 4. If you square the top, it's not equal to 4 over 49. And if you don't believe me, you could check. 4 over 49 is not the same thing as 2 over 7. So I just proved that you can't just square the top and bottom and have the same thing be equal. That's one mistake. The other mistake people do is they say, okay, well, let's do this. Let's square the bottom. And instead of saying squared, let's just multiply it by itself. That'll get rid of the radical 2. In some ways, you'd be right. In some ways, you'd be wrong. And I'll show you why. You can do this. This is fine. You haven't made the same violation of an equal sign. This is still fine. It's still equal to the same thing. But the bottom doesn't work out like you think it might. You'd get x squared, right? FOIL. And then you'd get negative root 2 times x. And then another negative root 2 times x. Running out of space here. Let me move over. Another negative root 2 times x. That x is outside of the radical. It doesn't really matter for our purposes. Then you would get negative root 2 times negative root 2, which is positive 2. Root 2 times root 2 is just 2. But look, you have these middle terms, these negative middle terms. You'd end up with, negative 2 root 2x, which is no better than you were before. So neither of those approaches is best. What you can do and should do is something, I'm going to leave this up so you can see the difference. If you multiply, instead of by itself, if you multiply the denominator with this radical, the whole thing is we're trying to get rid of the radical. That's what the answer choices are showing us. Multiply by the, what's called the conjugate. X minus root 2 times x plus root 2. Now, if you multiply the bottom times that, if you want to keep it equal, you got to multiply the top by the same thing. And if you do this on the bottom, this is called the difference of squares. You get x squared. You get the outside term, which would be positive root 2x. The inside term, which would be negative root 2x. Those would cancel. And the last term, negative root 2 times positive root 2, is negative 2. So gosh, I'm running out of room again here. I'm going to do that again so you can see, just to be clear. We haven't done the top yet. The bottom is x squared plus the outside term would be root 2 times x. The inside term, negative root 2 times x. Those cancel. And the last term would be negative 2, right? Root 2 times root 2, but there's a negative sign. So we have x squared minus 2 in the bottom. And in the top, it's actually, you could keep going and you could multiply these, but this is another example of how they want you to notice something. You have, I'll just write it, x squared minus 2 times x plus root 2. And you would be multiplying everything here, right? But I'm actually not going to do it. Follow me up here. Let's get some more space. Follow me up here. I'll write what we have, x squared minus 2. And we have x plus root 2. You can look, this here is a difference of squares. In the bottom, we have x squared minus 2. I mean, there actually may have been another way of doing this now that I recognize it, and I'll show it to you in a second. These terms, x squared minus 2 is on the top and bottom now. They cancel. The whole thing is equal to x plus root 2, which is answer choice D, if you can see right over here. Let me show you a different way to arrive at the same place. So if you recognize the top as a difference of squares, that is sort of the reverse of what we did. We just did, x minus root 2 times x plus root 2 in order to get rid of the denominator. Well, I can see this is equal to x squared minus 2. That's a difference of squares. These things multiply to be this, right? We'll do it out again just to be clear. X squared, outside positive root 2x, inside negative root 2x, last term negative 2. These cancel. We get x squared minus 2. So what does that mean for our work? Well, what it means is if I could take the top and factor it this way, instead of writing x squared minus 2 over x minus root 2, I could write this as the factors of x squared minus 2. X minus root 2, x plus root 2, over what it's already over, x minus root 2. Now these terms cancel, and we're left with x plus root 2. Difference of squares comes up a bunch on the test. I just showed you two different ways. You can either make the bottom, get rid of the radical, that comes up a lot on the test, or recognize that the top can be factored to be the bottom times its conjugate. the bottom times x plus root 2. Then they cancel. Okay. Difference of squares, huge concept on this test. 24. Which of the following represents the positive number r increased by 5%? Okay. Point zeros. Here's the way to think about percent. Let's just talk about what percent really means. Per is division, cent is 100. 5% is 5 over 100, which is equal to 0.05. But an increase, r increased by 5% would be r plus 0.05 times r. That's 5% of r. So to be clear, per means divide. Cent means 100. And in these situations, the word of means multiply. So if I say 5% of r, that's 5 over 100 times r. You have to add that to the original r to get 1r plus 0.05r is 1.05 r. That's your answer. So A represents 5%, B represents 5% less than the original, so that's a decrease of 5%, and C is the right answer. D is just off. Okay, cool. 25. Median of the data set summarized in the table. Okay, so here's what you got to know right away. It's not going to be the middle number. It's not, the median is the middle number. But it's not going to be the number that just looks like it's in the middle. This 3. It's not going to be that. It might be the 2, but it's probably not. Like, this middle bar is like where people are going to get themselves into trouble. What you have to do is think about how many total numbers do we have. What this data is showing us is that we have the value of 1 once. We have the value of 2 4 times. And I wouldn't write this out all the way on the test, but this is just for teaching. We have the value 3. The frequency happens, that is, the 3 happens twice. 3, 3. The 4 happens 3 times. And again, I wouldn't write this all out on test day, but here we go just for the sake of explanation. 5 happens 7 times. I'm running out of space again. 5 happens 7 times. 1, 2, 3, 4, 5, 6, 7. And you would look for the middle term here, right? So you could just count the middle term, and people do this kind of game, but I don't want to do that on test day, right? What I want to do is I want to say, how many total numbers do we have? We have 1 plus 4 plus 2 plus 3 plus 7, otherwise known as 17 numbers, right? This is 10 numbers. Another 6 is 16. There's 17 numbers. The median would be the 9th number from either end, right? You would have 1 through 8, then you have the 9th, and then you have another 8 numbers, which would be 10 through 17. Sometimes people get confused about this 10 through 17. They'll be like, that's 7 numbers. 11 through 17 is 7 numbers. The 10 is the 8th number. Right? There are 7 numbers after 10 to get to 17. I know that's annoying and tricky. The 9th number is what we're looking for. Doesn't mean we're looking for the number 9. We're looking for the 9th number from either order. So start on the end where you don't have to count as much. Here's 7 numbers. The 8th, 9th, and 10th number going down would be right here in this 4. Right? That is, the value of 4 is the 9th and 10th, 7th, I should say the 8th, 9th, and 10th number from the end. If you weren't sure, count it from the other end. Here's 1, here's 4 more, so that's 5. Here's 2 more, so that's 7. The 8th, 9th, and 10th number are all a 4. So the 9th is what we're looking for. It's a 4. Look, charts are made to be intentionally hard. This is about test awareness. If this was number 2, it'd probably be something that looks like, the median. That is the thing right in the middle of the page. It's number 25 out of 30 multiple choice questions. It's getting hard here. It's not going to be the thing that just jumps off the page right away in this situation. I've seen it happen over and over again. So be ready for that. Okay, big long word problem. Start with the last sentence in number 26. Okay, the last sentence is most of it. So look, if I'm gonna have to read all this junk, I'm going to pull stuff out as I go. 60 gallons, 60,000 gallons at the beginning. Begin. 550 is the average speed. I know I didn't read that first sentence. I'll come back to it. Remaining fuel. Fuel remaining. That's what, A? And T is hours. Okay. 5 gallons of fuel per mile flown. Okay, look, let's just figure out what happens then in 1 hour or in 2 hours. Something like that. If you use, and you could do some multiplication here, I'm just not going to do that. Well, I am, but I'm going to think carefully about what I'm multiplying. In 1 hour, I'm going to do 550 miles. And if I do 5 gallons every mile, then I better multiply that by 5. 550 times 5 is 250 plus 2,500, so that's 2,750 gallons. Wow. It's a lot of gallons in 1 hour. 550 miles, 5 gallons for every single mile. Making sure it wasn't 5 miles per gallon, which is what we usually kind of say in this situation. In this case, 5 gallons for 1 mile. 2,750 gallons in 1 mile. Look, it's got to be D then. That's a slope. But I could figure this out if I wasn't sure about that. I could say 2 hours is what this times 2 is 1,100 miles, which would mean times 5. That's a nice number. 5,500 gallons when we have T equaling 2, or, we had the T equaling 1. And you would just try these numbers out and solve it if you weren't sure. That's how many gallons. So I should be careful here. Do we want to know how many gallons we have? Yeah. So we don't want to know how many gallons we use, but how many we have left. That's why D is right. You take the 60,000, you subtract what you've already used, 2,750 miles or gallons in 1 mile. Gosh, I misspoke. 2,750 gallons in 1 hour means that if you had 60,000 gallons of fuel at the beginning, you subtract that every hour. Right? So what did I do here? I used a real number. Every time you have variables in your answer choices, that's an option for you. And especially on these word problems, it makes a lot of sense because you're less likely to catch your mistake if you just take an algebraic approach. So instead, just use real numbers. All right, 27 asks you to have no real solutions. Which of the following must be true? There's a few ways of doing this. The most sort of reliable way is to use the discriminant. So what is the discriminant? Well, it's part of the quadratic formula. The quadratic formula is more than just one formula. It's also a grouping of two pieces. Negative b over 2a. That is the x-coordinate of the vertex. Not that important or directly important here. The other piece is the discriminant. B squared minus 4ac. If it's positive, then two solutions. If this is 0, then you have one solution. If this is a negative value, you have 0 solutions. That's confusing if you don't understand why. So think about this. If you have whatever you have for negative b, you have plus or minus. Let's pretend this is a positive number over 2a. And in fact, let's make it a positive number we can work with. Let's make it 100. Just for the understanding of what a discriminant does. If that's positive 100, you're adding and subtracting the square root of 100, which is 10. Your answers would be negative b plus 10 over 2a, which is different than the other answer, negative b minus 10 over 2a, plus or minus. So you would have two answers here, two solutions. Now, if this were a 0, you only have one solution because you would have negative b plus the square root of 0, which is a 0 over 2. That's the same as negative b minus 0 over 2. The zeros don't change anything, and so you have one solution if you have 0 as your discriminant, b squared minus 4ac. This thing I'm doing down here, remember, that's just this piece. All right. Now, if last thing, and then we'll attack this question directly. If this is, say, negative 100 over 2a, that's an imaginary number, right? So that's like, I think, 10i. But we don't have any real solutions here because you can't add and subtract a square root of a negative number. No real solutions. And you'll see that language in this case. Notice it says, sorry for my bad handwriting. You get what I'm saying. No real solutions. That's what we want. So let's, I'll just clear this last little piece, but I'll leave all this other stuff up. If we want to figure out no real solutions, what we're doing is we're just saying b squared minus 4, the a value. This is the standard form we talked about before, ax squared plus bx plus c equals 0. So 3x squared plus bx plus 5 equals 0. Sometimes they'll mess with you with these variables. This was actually quite kind of them. Sometimes they'll make this an a, which is confusing because it's still in the place of and functioning as a b. So be mindful of the fact that it doesn't matter what you call this letter. In standard form, that's the b. It goes in this part of the quadratic equation, this part of the discriminant. B squared minus 4 times our a value. A is 3. C is positive 5. We need this to equal a negative value. Negative value. So, okay, let's figure out what this is. B squared minus 12 times 5 is 60. So b squared has to be smaller than 60. Answer choice A. If b squared is smaller than 60, we get a negative value. Right? Not so hard. If you know what you're doing, that one's fairly simple. I said there was other ways to do this. In this case, I don't think there's any other great way to do this, so I won't confuse things by giving you some less than optimal approaches to that question. 28. Okay, perpendicular and intersect at the origin. Okay, so the equation for line Q. Okay, this is interesting. If they intersect at the origin, it's y equals mx plus b is the normal form of the equation that tells you about slope and intercept. And this means that for line Q, maybe I say q of x equals some slope that I don't know. Mx plus, they intersect at the origin. So that's that y-intercept is 0, right? When x is 0, what is the value of y? Well, if it goes through the origin, 0, 0. Right? So this is the equation. I don't know what the slope is yet. For q of x, though, I can say when x equals 1, oh gosh, I don't know anything about q. So let's talk about r first. I thought we had given a point for q. We'll come back to q. For r of x, we know the same thing, some other m value. So I don't know what m is here. So maybe, you could replace m in this case with something else like a. And I'll do that just to be clear. Ax plus 0. Or just ax. Here's what I know then. When r has, r of 1, when x is 1, we're supposed to get k. Ax equals k. Oh, what am I talking about? Ax. I'm like, what? The x is the 1. So replace that. What does that mean? That means the slope of my r equation is k. I know that's confusing. That's why it's number 28. All we know is that this is the slope. And that's enough. That's what we wanted to figure out by plugging in the point. This was just a placeholder, this a. I could have written an m, but I didn't want to confuse you and think there's two m's or something. They're just the slope. I just put a placeholder in there, and I said if x is 1, the y value is k. Okay, well that means a times 1 is k, which means a equals k. And again, a is just the slope. So the slope is k. Right? If you want an extra step just to be absolutely clear, you could say a equals k. That's what we got here. A times 1 equals k. So go back to the first equation that I wrote for r, kx, and I won't write the plus 0 this time. Slope right here. I know that's confusing. It's intentionally confusing. I will show you something else we can do in a second if it makes you feel better. To finish this out in the traditional way, you would go and say, well, the q equation, I know what the slope is then. I don't really know, but it's, it's perpendicular to k. So opposite, reciprocal. If you have a slope of k, perpendicular to that is 1 over k. And then we already know the y-intercept is 0. So this is the entire equation. The slope is this right here, negative 1 over k. Equation for q would just be, q of x or y equals negative 1 over k times x. Which is answer choice C. It looks a little bit goofy. Negative x over k. Yeah, it's B. That looks a little bit different, but if you multiply negative 1 over k times x, you get negative x over k. All right, if that felt really confusing to you, stick with me. I'm going to give you another version of this. Let's say line R, and I'll use the y equals form. So line R, I won't say r of x. Line R is y equals some slope I don't know plus 0. And I know that there's a point 1 comma k. I'm going to make k equal a number. Let's make k equal 4. All right. So this is me saying, like I said on an earlier question, if you have variables in your answer choices, you can totally pick numbers. Okay. If k equals 4, we have the point 1 comma 4. And now you can plug these numbers in. Y equals 4, x equals 1. We don't know what the slope is yet, but we're about to figure it out. Plus 0. 4 equals m times 1, or just m plus 0. So we just figured out that the slope of line R is 4. And you're like, wait, you just picked that randomly. I know I did. It's going to work. Line Q, the important piece of information that you can't do this question without is knowing perpendicular slopes. The slope of line Q is going to be perpendicular to line R. Perpendicular means opposite, which means opposite sign, and then reciprocal, which means flip. 1 over 4 times x. That's your equation. You could say plus 0 because, again, it goes to the origin, so that's the plus 0. So what's the equation for line Q? This is it. How did they write it? In a slightly goofy way where they multiplied negative 1/4 times x. That's equal to negative x over 4. So y equals negative x over 4. Of course, C is just a way of messing with this 1 that you saw in the equation. I almost made that mistake. Using real numbers can help clarify any concerns that you have about stuff like that. You can pick a value for k as long as you're consistent with what that value is. Let's keep moving here. Number 29. Okay, kind of a classic. Here's the deal. Circles are proportionate. So 60 degrees out of 360 degrees, it's 1/6 of the circle, right? So we have 1/6 of the area of the circle. We also have 1/6 of the circumference and all that stuff. We know that the radius of this circle is, so let me just say this, the degrees over the total degrees, for the degrees of the central angle, that's equal to the arc length, AB, over the circumference, which is 2 pi r. And also it's equal to the area of segment AB. Let me kind of draw you what I mean here. I'll just make a quick little circle drawing. I'll put it over in the corner here. Look, if you have this 60-degree angle, this area here, I'll just say area AB over the total area, pi r squared. So all three of these things are true. You have 60 degrees out of 360 total degrees of a circle. You have that arc length AB, the minor arc, that is the shorter distance, not all the way around, that's the major arc, but the shorter distance AB over the circumference, and you have the area of the segment AB, this thing that I've shaded in, and I think that's what we need for this question. So look, I'm going to go right to that. I'm going to simplify 60 over 360 is 1 over 6. I could have kept it as 60 over 360, but it's easier this way. The area AB, I'll just write area AB still. Or I could write segment area. Over pi r squared, that's the r is the radius. So the area of the whole circle, pi r squared, would be 16 pi. So what we're saying is we have 1/6 of 16 pi. You could cross multiply and solve it. If you want, call this x over, so instead of writing area AB, write x. Cross multiply and solve. So 1 times 16 pi, and then, what I'm calling now x times 6. So 16 pi equals 6 times this area AB. I'll still just write area AB so you can just see what I'm doing. If I want to know what area of that AB segment is, and again, when I'm referring to that, I'm referring to this whole slice of the pie. Divide both sides by 6. You get that all by itself. 16 over 6 is 8 over 3. Pi equals that little area. Now, we're not done. Because like I said, we just calculated the area of this whole segment. We now have to deal with this triangle. So let's do that. That triangle is a 60-degree angle, which is a special kind of triangle. So let me just talk to you about that 60-degree angle here. I'm going to roughly draw... We'll see how roughly. Pretty roughly. I'm going to draw that 36 or that 60-degree angle. So these are all 60s. Because look, maybe what's best here is if I take this and I put it on the board so I can really show you what I mean. I'll do that. Let's take this figure and let's put it on my chalkboard. Sometimes this takes a minute, so bear with me. Here we go. All right, and I'll kind of blow this thing up. Let's give ourselves some more space and put this over here. Yeah, that's good. I'll put it up here. All right, so look, this is because it's a radius. If this is 60 degrees and this is an isosceles triangle, they have the same two lengths. Two lengths are isosceles. So that means that the remaining degrees, you have 180 degrees in the circle. 360 in the circle, 180 in a triangle. If you subtract the 60 we know about, we have 120 degrees left. That 120 degrees has to be split evenly among these two angles, which means these are 60-degree angles. So they're all 60-degree angles. We have an equilateral triangle. So here's what I'm going to do for my equilateral triangle now that I know that. So I'm going to get rid of that stuff. I'm going to cut it down the middle. Because there's something I know when I take my 60-degree angle, and maybe what I'll do just to make it visually a little bit better is to cut it down the middle this way so I don't have to cut up that 60. That means this is 30 degrees. I just drew an altitude down to make this a 90-degree angle. Look, I did all this because now I can easily calculate the area of this triangle. If I want to calculate this shaded region, what I have to do is I have to calculate the area of this triangle and subtract it from the area of the segment, which I've already figured out. So the 30, 60, 90, knowing about 30, 60, 90s really helps here. For 30, 60, 90, the side lengths are x, x root 3, and 2x. We know what 2x is here. So by the way, this is the 30 degrees, and this is the 60, and this is the 90. So our 2x is a 4. Our x root, that means our x is a 2, and our x root 3 is just 2 times root 3. And clear that up. 2 root 3. Why does that matter? Well, because the area of a triangle is about the base, 1/2 base times height. Well, the base of this triangle is 4. Half of that base is 2. The area of this triangle would be 1/2 of our base, which is 4, times our height, which is 2 root 3. So for the whole triangle, let me just draw the whole thing so that you're clear that I'm talking about the whole triangle's area, half of the base of 4, so that's just 2, times 2 root 3, and that works out to 4 root 3. You have to subtract that from the segment area. So to finish out this question, that would be 8 over 3 times pi, that whole segment, minus 4 root 3. And if I remember correctly, the answer is given in kind of a goofy way. Yeah, all they did is pull a 3 out. They said factor the 3 out. Then you have 1/3 times 8 pi minus, and if you're gonna pull this 1/3 out, then this becomes 12 root 3. So that if you had multiplied this 1/3 back in, you'd get 8/3, and you get 12 over 3. Best advice I can give you on this question. Look, there's a lot of pieces there, but none of it's complicated. I mean, what you got to know is you got to know 30, 60, 90s, equilateral triangles. You got to know that circles are proportionate, right? So I know I had 1/6 of the total area, 1/6 of the arc length. I knew that I could calculate the area of the whole circle and divide that by 6. That's how I get my 8/3 pi. I knew that I could calculate the area of my equilateral triangle, once I proved that it was equilateral, by using what I know about 30, 60, 90s. Those, by the way, are given to you on the front of the test, so we can all look that stuff up, though it's good to know it in advance. And aside from knowing that stuff, it's really important that you don't go and crunch a bunch of numbers here. By that I mean to say, look, I left it as 8/3 pi. I didn't figure out what the heck 8/3 pi is as a decimal. It'd be a horrible mistake to do that, because then you'd get to the end and you wouldn't know what these answers represent. So look, if the answers were decimals, then go for decimals. But if the answers are in these crazy terms with radicals and pies, then leave them in those terms when you calculate. And it's important to be able to calculate that way, right? So notice on the bottom of the page here, look at this calculation. I mean, this right here was me saying these 2's cancel, and you just have 4 root 3. Right? Over here, you saw me do 16 pi equals 6 times this weird area. And then when I divided by 6, I didn't go to my calculator. I just said that's 8/3 pi. Get comfortable thinking like that when the answer choices are in that form. Hard question, but it's certainly a gettable question. There's literally not one of you that can't calculate those pieces individually using these small, not that complicated ideas. You can definitely get there. And that's supposed to be a really hard question. So, I mean, in some ways it is, in some ways it isn't. All right, look, the first thing I'm noticing about number 30 is that the answer choices have variables in them. So that means I'm going to try just using real numbers. Probably. We'll see. Let's read this question. So go to the end of the question. Always do that. Go to the last sentence. If 6 students have no siblings, which of the following represents the situation? So I'm just going to write 6, no. I'm always like sort of writing down to the side little bits of information. There's 30 total students. 30 students. Okay, this is that silliness that they like to pull sometimes. This language is crazy. The number of students who have one sibling is 3 times the number of students n who have 2 or more siblings if 6 have no siblings, blah, 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 blah. Okay, look. If there's 30 students and 6 have no siblings, that means 24 have some siblings. Yes, siblings. Yes, siblings. Anyways, look. It looks... I'm not going to set up an equation first. What I'm going to do, because the answers are equations. I don't need to set up my own. The one sibling kids are a lot. The ones that have 2 or more are less, because it says the group that has one sibling is 3 times bigger. Okay. I'm just going to try out some numbers here then. Look, let's say I start with, I can already see what it is, but if I said 20 have 1, then there would only be 4 that have 2 or more. And then you're like, well, does that make sense? The number of students n who have 2 or more times 3, so 4 times 3 is 12, so that didn't work. Okay, so maybe I got to try a smaller number. Why don't I try 18, and then there would be, I guess, 6 would be the other group, right? That was me just kind of skipping ahead, but if there's 6 that have 2 or more, multiply that by 3, and these are the number that have 1 sibling. Try out numbers. That's the best way you can do this. So the 2 or more is n. N is 6. Find one that works here. I don't understand exactly. Oh, yeah, these equations are goofy, dude. Yeah, that's what I mean. This is why the equations are goofy. So put in a 6 and try to get 30. It's going to be answer choice C. It just doesn't seem very intuitive that it's answer choice C. Right? 4 times 6 would give you 24, plus the 6 is 30. Why does that work? I mean, I can show you. So, the 2 or more siblings is n. The ones with one sibling are 3 times n. And then if you add 6, the other 6. So this is the 2 or more. This is the 1 sibling. And this is none. And those have to add up to 30. And then you could simplify and say that's 4n plus 6 equals 30. But I didn't want to do it that way because I don't want to fall into one of their stupid traps and not know that I fell into a trap and then not get into the college I want to go to because of some stupid question about the number of siblings said in a weird way. So just use real numbers, use logic and reasoning at the forefront of your thinking on these word problems. And then I shrunk the whole page. I'm going to move on here. We got 8 more questions to talk about. Let's talk about number 31. All right. So for how many of the 10 airports was the percent of flights with delayed arrivals less than predicted by the line of best fit? Okay, look, this is kind of murky looking, but delayed arrivals. Percent of flights with delayed arrivals. For how many of the 10 airports? Yikes. I think since the delayed arrivals is y, right? That's the y value. So we're interested in this y value. There's this line of best fit. The percent of flights with delayed arrivals less than predicted. The line of best fit is the prediction. So all the points below that have a lower y value. Percent of flights with delayed arrivals, and that's what we want. We don't care about the other part. Yeah. So how many dots? 1, 2, 3, 4, 5, 6. That's number 31. Cool. 32. Some geometry stuff. What is the measure in degrees of GCF? Okay. Not so bad. There's some things I don't know about this to begin with, but there are some things that we can definitely do to begin with. So that's my bad drawing. Let's go with it. 65, 75. You have to be able to see these overlapping triangles. So subtract those from 180. 180 minus, what is that? 75 and 65 is 140. 40 degrees. Ah, yeah, I'm such a dummy. This is the 40 degrees right here. No doubt that's the 40 degrees. They told that to us, Jeremy. Okay, so we know that A corresponds to E. Okay, that means this is 65 degrees. They're congruent, right? So that's 65 degrees. And B corresponds to D, so this is 75 degrees. Which means that for this triangle, 40 degrees. I mean, when I'm talking triangles, I'm seeing this big triangle, comparing that with, this big triangle. And now I can tell you that 180 degrees minus these two 40s is 100 degrees. So 180 minus 40 leaves 100. And that's what they wanted, right? GCF. Be on the lookout for them asking you questions about like these guys, which would be a little bit harder but totally solvable. Four-sided figures, if you ever wonder how many degrees in a total figure, it's n minus 2 if n is the number of sides, times 180. But a four-sided figure always has 360 degrees, and a straight line is 180. So I could tell you that this is 140, and I could tell you that this right here is 80. And you could see that all four of these add up to 360. 75, 65 is 140, plus another 140 is 280, plus another 60 is 360. So just in case they ask you a slightly more complicated question, there you have it. 33, what is the value of m, they ask. Okay. The slope, sure, we can calculate the slope. First thing I did was check to see if the grids were like actually 1-to-1. Making sure this wasn't like 10, 20, 30, 40 or like 2, 4, 5, 2, 4, 6, 8. But they're not. So this one's actually fairly straightforward. The slope is up 1, 2, 3 over 2, slope of 3 over 2. Right? 34. What fraction of the cornfields, go all the way to the question first, the last sentence. What fraction of the cornfields were where an eye spot was observed needed fungicide? Okay, what fraction of the cornfields where an eye spot was observed? Let's just figure out what that was. There's a total of 40 an eye spot observed. So out of 40, needed fungicide, 30 out of 40, 3/4. You have to reduce in order to get the points on that question. So first I figured out what my total was. My total is the cornfields where an eye spot was observed. Eye spot observed here. Boom, the total is 40. This total is the total with fungicide needed. That's a different number. Of the 40 where an eye spot was observed, which ones needed fungicide? 30. Making sure there wasn't like a not needed bit. But look, I didn't even have to read this information. Sometimes you do, sometimes you don't. Well, always, start with reading the question because who knows if you're going to need that other information. So it's, again, another question about m. In this case, I don't know what m is, though. What is the value of m? The average rate of change in miles per year of the total length of major commercial railroad tracks in the United States. Total length of major commercial railroad tracks is literally just the y-axis, the points on the y. From 1916, the very beginning, to 1926, just this line right here. All you got to do is calculate the slope. So rise over run, rate of change is slope. Rise over run, let's just do it this way. Sometimes what I do, this is another way of saying rise over run. The difference in the y's over the difference in the x's. Biggest mistake people make is mixing up x's and y's and putting these in the wrong places. So I'm going to take 421. I'm not even going to worry about the thousands. I will. And I'll put that over the x value of 1926. Minus, then put in the stuff for the other point. 397,000 over 1916. I didn't want to lose my zeros along the way. So like this is 21 and then another 3. This is 24,000. what I just did there is I just said this is 21,000 to get us down to 400, and then another 3,000 more to get us to 39.7. 24,000 over 10, cross off a 0, 2,400 over 1, or just 2,400. Rise over run. 36. Go to that last sentence first. What fraction of the total number of houses the crew painted in July and August were painted in August? I don't know. Let's see. 20 houses in July. In August, the number of houses the crew painted was 20% more than they painted in July. Okay. So remember, 20% is 20 over 100 or 0.2, 0.20. But 0.20 more means that you should say multiply by 1.2 times the July amount. Let me say this. Let me write out the translation a little bit more explicitly for you in case these are messing you up. 20% more than July. That means 0.20 times July plus July. This is the additional stuff, and this is the original stuff. Another way of saying that is this is 0.2 July, and this is 1 July, so that's 1.2 July, or 1.20 July. Sometimes it helps to see that 0. 120% of July. 100% of July would be exactly just no more, just the exact same amount, 20% more. And then 1.20 times 20. Well, that's, I think 24. You could put that in your calculator, of course, but you would have 20 and then 20%. So 1/5 is 20%, 20 over 100. So sometimes you can think of percentages as fractions. They are the same thing. 20 over 100 is 1/5. 1/5 of 20 is 4. Add that 4. 20 plus 4, 24 houses painted in August. We're not done. Oh, they want to know what fraction of the total houses the crew painted in July and August were painted in August. Ha ha ha. Well, we know that there was 24 in August, so this is August, over the total, which is 24 plus 20 or 44. And then we would have to reduce that. Top of my head, first thing I think about was we could divide both of those by 4, and we can get 6 over 11. 6/11. That makes sense to me because I'm thinking, if we have 20% more, 5/11, it gets confusing to talk about, but 5/10, 20% more than 5 is 6. So you have the 20% more is the 6 and the 5. That might be more confusing than it's worth. Bottom line is you can calculate this 20%. If you want to do 20% more, that's how you get 24. And this one's built in with a eureka mistake because I was like, yay, I got it. It's 24. But there was one more part of that question, which is what fraction of the total were painted in August? So the total wasn't just July, it wasn't just August, it was both. All right, 2 more questions, and then you and I are done with this test. Look, a percentage question again, so let's keep going with this percentage idea. The price decreased by P% to $9,600. So how much did it decrease in actual dollars? Let's figure that out first. So it ended up it didn't go down by $9,000. It ended up at $9,600. So how much did it go down? Well, there's that number again. 2,400 is the number. And we want to know what percent that is of the original. To know how much percent it went down, say, well, what is that as a percent? 2,400 or 2,400 over 1,200, 12,000, I should say, equals something I don't know as a percentage. Per is divide, cent, 100. Cross multiply and solve. If you want, you can get rid of a couple zeros first. 24 over 120. If that confuses you, don't worry about that. but I got rid of a couple zeros. 24 over 120, and you could cross multiply. 120x equals 24 times 100, which is 2400. Divide both sides by 120, and you'll get x equals, what is this here? 240 over 12, which is 12 times, is that 20%? Yeah. It is 20%. X is 20%. Makes sense. It went down 20%. Sometimes I'll check my work with logic. Like, yeah, $2,400. Like, I don't know. I know that 25%, a quarter of it would be $3,000, right? A quarter of 12 is 3. So $3,000 would be 25%. We did less than 25%, less than $3,000. Makes sense. It's 20%. Another way to think about it is 24 1/5 of 120? Yeah, totally is. Or, so many ways you can think about it. But hopefully that's helpful. Moving on to the last one. Aha, this looks scary. I bet we don't have to solve for T and U. 9 times out of 10, you're not going to have to solve for both of those messy, gross things. Here's what I'm noticing. We talked about systems on an earlier question. I'm just going to call this A plus B equals 37. You're like, wait, you're not allowed to. A minus B equals 19. Look, because this A is the thing I care about. I mean, it's, just so we don't get lost, what A is 1/3 T plus 5, and B is equal to 1/2 U minus 4. I'm going to just say, look, I can figure out what A is really quickly. Add these two equations up. You'll get 2 A's. These B's will cancel, and you'll get 37 plus 19, which is 56. Divide by 2, A is 25, and 3, 28. A is 28. Okay, so that's what A is. Let's figure out what B is. Well, how can I do that? Well, look, if A is 28, go back to either of your equations. Maybe I'll do this second equation. A minus B equals 19. 28 minus B equals 19. B, we'll subtract, I guess. Subtract 28 from both sides. Maybe I should have picked the other one so I didn't have to do subtraction. I don't like subtraction as much as addition. I know that's weird, but that's me. Negative B equals 19 minus 28. Be careful. Is that negative 9? Is that negative 11? Negative 9, I believe. I think B is 9. I'll double check my work up here. Yeah. And look, I'm being honest with you folks when I get a little bit tripped up, and I hope that's helpful for you to see how you should be humble about little things like that are kind of messy for you. Especially, I've been talking here for an hour and a half. So B is equal to 9. Let's just make sure it works in this first equation. 28 plus 9, yeah, that's 37. Okay, so I figured out what A is, I figured out what B is, and now all I have to do is multiply those, right? They're saying, what is, give myself a little bit more space, what is this thing, A, times this thing, B? Well, 28 times 9. And that's equal to, gosh, let's see, really put myself to the test here. 180 and 72, 152, I believe. I think. 180, 72, 152. Let's just check my work at the end here. Oh, no, what did I do wrong? Oh, 252, you dummy. 180 plus 72, yeah. How am I going to get a smaller number? 252. Okay. So I hope that was helpful. I just want to peruse this section one more time to just show you how many things came up that I think are classics, things that you should totally look out for. Percentage stuff is a huge deal. Came up on 36 and 37. Systems of equations came up on number 38, and way back on an earlier question. Let's see what it was. Not that early. Let's see where that question came up. There was a system question right near the beginning. A couple of them, actually. Number 17 was a system question. Number 21 was a system question. And we had this difference of squares concept of number 23, super important. We had the parentheses are kind of weird situation and knowing the vertex equation on number 22. We had sort of what I call the wise ass answer approach to number 20. And I think there was another one of those sort of interpreting equations. Number 19 was actually kind of like that too. We had the translating units thing on number 18, very common. We had understanding the box plot, not that common, comes up a couple times. We used numbers on number 16 to simplify a word problem, right? We picked values for x that were easy to think about. We could do the exact same thing on, let's see, which ones did we do that on? There was a couple others. We could have used real numbers. I didn't do this on number 23, but you totally could have picked real numbers for number 23. Why not? Use your calculator. Just throw a value for x in and see which one works if you don't know what else to do. I talked about difference of squares. You could totally throw numbers at it. Anytime variables are in the answer choices, pick x is 0. Then you want to get, root 2 over 2. And root 2 over 2 is, 2 over root 2, negative root 2 over negative root 2, or 2 over root 2 is the same thing as root 2. So, you could do that approach and get answer choice D just by picking numbers. I picked 0 and just figured it out on the fly. More percentage stuff on 24. More just like using real values on number 26. This was a discriminant question, right? The idea of no solutions, that's important. This was that classic median mistake on number 25. So many classic things. 28, we picked real numbers. 30, we just kind of like worked through logically with using kind of guess and check with some numbers. Variables in the answer choices, try real numbers. Number 29 was that ratio idea, right? This idea that the circle is a ratio. All these concepts come up again and again and again. Best thing you can do for practice, go find other questions that look like the ones you were messing up or the ones that you thought were hard. I guarantee you can find everything I just talked about in this little review is stuff that I see over and over and over again on the 20-something SATs that we have copies of. If you go through all of them and find questions, you will get better at this test because you'll be like, it's one of these. Same way I did. It's one of these questions. Right? So hopefully that's helpful. One last thing I'll say, I say this all the time, study with friends. Go over questions with friends. Teach friends questions. Argue with friends about questions. Do whatever you want. Email me if you want some extra help. If you have clarifications, comment in the videos, whatever you want to do. Reach out if there's other questions you want me to answer. Talk smack, enjoy yourself, and take care. See ya.